Hey everybody, Jason here, and in this video I want to give you a short introduction to our brand new robotics image that we've made available for the FPGA on XLR8. In addition to that, we'll introduce you to the new Quadrature accelerator block that's available as part of the robotics image and show you an example sketch so you know how you can take advantage of that XB. So let's go ahead and jump into it. The first thing that we're going to want to do is make sure that you have the latest version of our boards package. So we're going to jump out to the boards manager, and we will search on Alorium. Now, I have 1.7.0 currently installed. The latest version is 1.8. So we're going to grab that and update it, and we'll let that install, and that will give us the new images as well. So now that we have that installed, we can go down and take a look, and what we want to do is we want to select this 16 megahertz robotics image, and we are going to burn that to the FPGA. So we select that image. Now make sure that's selected, make sure we have the port set, and we go to Burn Bootloader, and we are going to click on that. Before you click on Burn Bootloader, one of the things you want to make sure you do, make sure that your serial monitor is closed, because if that's open, you're going to have trouble. So let's click Burn Bootloader, and we'll allow that to run. Okay, that is complete. We sped up time there a little bit. That takes a couple of minutes, but we can see that it's done. And it's reset the accelerate. But now what we want to do is we actually want to explicitly run get accelerate version, and that's the sketch I have open here. So we're going to do that just to make sure we know exactly what image is on the FPGA, and that's running on accelerate. So we'll rerun that sketch. I sped things up a little bit there, loading it again. Now let's jump down. We can take a look here. We've got the 16 megahertz servo and quadrature image. That is our robotics package. So it's got the servo XB, the Quadrature XB, so we are ready to go. This is the robotics image. Now let's take just a minute to talk specifically about what is on the robotics image and how it maps to the I/O on XLR8. Okay, so here we are with our XLR8 board, and let's go ahead and gray that out so that's a little bit easier to see. And the first thing we'll do is look at how the servo pins map to the XLR8 I/O. Now, as you can see, you can connect a servo to any one of the pins from D1 through D13 on one side of the board and D14 through D19 on the other side. D14 through 19, of course, being more commonly associated with A0 through A5 on the analog inputs. But you can map a servo to any one of those pins using our servo XB. And our library works just like a standard Arduino servo library. Once you include that, all the other functions remain the same. We've done other videos and have other resources on that, so we're not going to focus on servo in this video. But let's take a look at the quadrature mapping now. And the way quadrature maps is quadrature actually maps from D2 through D11. Now, one of the things that's important to understand about the quadrature library that we need to draw your attention to is that these pins map in order. That is, as you instantiate quadrature blocks, they map from the smaller pin values to the higher. So you can see how they're kind of grouped here in pairs, and there are 5 quadrature interfaces in the robotics image, and so these are where they map as you instantiate them. Now you can just choose to instantiate one of them, and the first one will go on pins 2 and 3, and then it'll go through 4, 5, 6, 7, on and up through 11. But they do go in order, and there's more on that in the library documentation as well as in one of the sample sketches. But the other important thing to be watching for is that you need to make sure if you're going to use servo and quadrature that you do not overlap them. Technically it's possible, but it gets pretty complex and complicated, so it's just easier to avoid that for right now. So you'll want to assign your servos to other pins and just allow those quadratures to go where they must go, which is on pins 2 through 11. Okay, so enough about that. Let's jump back into looking at some code and how you actually use this thing. So we're going to do that by looking at an example sketch called Simple Quadrature. And in order to get that, we want to make sure that you update your libraries by going to Manage Libraries under the Sketch menu. And you can go here and search for Alorium. And if you scroll down, you will find the Accelerate Quadrature. There it is. You can click the Update, and you should get version 1.1.0 will be the latest and greatest version of that library. And now once you've done that, if you go over to File, Examples, and scroll all the way to the bottom because we chose to start our name with an X, you get down here, it's Accelerate Quadrature, and you'll see that Simple Quadrature is now one of the example sketches that you can run. So let's take a look at how you run that and what you can do with it. Okay, so let's do a quick walkthrough of this code. First of all, you'll see that we include our Accelerate Quadrature library, which of course we're going to need to be able to use it. And then the next step is to instantiate one of our quadrature blocks. In this case, I call it quad 0. There are a handful of other variables here that we have defined. We jump down to our setup block where we set up our serial port at 115.2, add a little nice header in the serial monitor so we know the sketch is running. The next step is to set the quadrature sample time to 200 milliseconds. You can set that to 20 milliseconds as well. Those are the options right now, sample 200 or sample 20. So in the main loop, we've got some code here that every 500 milliseconds or every half a second, we will go out and read the rate and read the count from the quadrature. And we'll look to see if anything has changed since the last time we checked it. If it has, we will just print it out to the serial monitor. So pretty simple code, just really basic stuff that we're doing, not doing any fancy math or anything like that. So let's take a look at what this looks like when we're using it with a real quadrature block. And of course, in order to do that, we need to actually upload it. So we're going to make sure that we've got the right port set and we're looking good there. We're going to upload this and we'll let that go out to the Accelerate board. Okay, so we're good. Let's check the serial monitor and let's also bring up a little video to show you the setup that I've got that I'm using for testing this. And what I've got here is pretty much just a simple little motor that it's from DF Robot. So it's a little electric motor that was used for a robotics project and it's got a quadrature encoder on it. So we've got the A and the B outputs from the quadratures. And what we're doing with those is we are just connecting those up to pins 2 and 3. So we're going to be setting those up as a single quadrature setup. Now, we're not actually powering this or anything, so we don't have anything driving the motor. I'm just going to be turning it by hand. So once this is uploaded, what you can see is as I turn it here, you can see the count changing in the serial monitor. And so I'm turning it clockwise right now, so you can see that the count is going up as we turn the motor, or as we turn the wheel. Now, if I want to go backwards, I can turn it counterclockwise and then the count will go back down. You can see that the rate is now going in a negative direction. So we know that we're turning the other way, and that would allow us, if we were monitoring things like that, to know which direction the wheel is turning and then how many times it's gone around. And there I can get it set back to about 0. So the other thing to notice is this rate value really tells you how many times a tick has gone by in that 200 millisecond period. And most of the time as I'm turning this, you can see it's 1, 2, things like that. I'm not turning it very fast. But if I give it a good hard spin here, you'll see that it jumps up to 9 or 10 and you kind of get that little peak in there. And so it's sometimes, obviously, if we had something running it, an actual motor driving it, you'd see a lot higher rates. Well, that is it for this video. We got some really cool demonstrations coming very soon that will show the power of putting quadrature blocks together with the servo control out in the FPGA fabric and the huge benefit it can give you over trying to do all that on a simple microcontroller. Very neat stuff coming, so make sure you keep your eyes on our Lorium Technology YouTube channel. As always, if you have any questions, please head over to our website, go to our forums. You can send us an email, you can enter it in the forum, ping us on Facebook, whatever you want to do. We love hearing from you, and we would love to help you get this going for your project, your product development. Thanks again for spending your time checking it out today. We look forward to hearing from you soon.